Module 7, Describing Chemical Reactions. Incomplete combustion reactions. The third type of combustion reaction we will learn about is an incomplete combustion reaction. You see, in order for things to burn, they need lots of oxygen. As I mentioned before, if you place a burning candle under a glass, the flame eventually goes out. That's because it has used up all the oxygen trapped inside the glass. So combustion needs a constant supply of oxygen to burn. But what if something doesn't have enough oxygen to completely burn up? If there's a limited amount of oxygen, a substance made of carbon and hydrogen will not burn completely, or we say that it undergoes an incomplete combustion. When this happens, carbon dioxide isn't one of the products. Instead, either carbon monoxide or just carbon results. So if we take methane or natural gas and burn it under limited oxygen, it can result in a carbon monoxide product equation like this, where methane and oxygen produce carbon monoxide and water. Or it will result in a carbon product equation like this, where methane and oxygen produce carbon and water. This really depends on how much oxygen is available in the area where the reaction is occurring. If there is a fair amount of oxygen, we'll get the first incomplete combustion reaction, where carbon monoxide is produced. If there isn't much oxygen available, then we'll get the second incomplete combustion reaction, where carbon is produced. When we get a carbon product equation, the product is often called soot, like the black powdery material you find on the inside walls of a fireplace. Now, as opposed to a complete combustion reaction that produces carbon dioxide, an incomplete combustion reaction that produces carbon monoxide can be harmful to people. You see, carbon monoxide is a poisonous gas. So if you are burning a material where there is a limited amount of available oxygen, you run the risk of causing incomplete combustion and producing harmful carbon monoxide. This actually occurs often, especially with the running of car engines. You see, most cars run on gasoline. They burn it to obtain energy. To do this, there needs to be a constant supply of oxygen. So the engine has to continually pull in air from outside the car so it can burn the oxygen gas that air contains. But the engine requires lots and lots of energy to run, so it has to burn lots and lots of gas. And gas burns very quickly, using up the oxygen in the air faster than the engine can pull it in. That means that car engines often burn gasoline with a limited supply of oxygen, resulting in incomplete combustion. And this results in a carbon monoxide product equation, making poisonous gas. That is why you should never, ever run a car engine in a garage with the door closed, or even stand behind a car near its exhaust pipe while it's running. Some of the combustion of gasoline is incomplete combustion, producing poisonous carbon monoxide gas, which could be deadly. 3 decades ago, the carbon monoxide production by automobiles was so large in the United States that there was a concern that the air was becoming poisonous for people to breathe. So in 1975, a law was enacted to require all automobiles to have catalytic converters installed. These devices help reduce how much carbon monoxide is released in a car exhaust by actually taking the carbon monoxide and converting it to carbon dioxide, which is a non-poisonous gas. But this only reduces the quantity of carbon monoxide that's released by car engines, so there is still some carbon monoxide in car exhaust, and you still have to be careful. Now, cars are not the only producers of carbon monoxide in the environment. Other combustion situations can occur where there is not a good supply of oxygen. For example, in cold temperatures, natural gas furnaces have to burn gas faster than the oxygen supply can be taken in. Then carbon monoxide will be produced. Much of that gas will flow out of the house through the chimney, but if there is not good ventilation, some can remain inside the house. Fires in fireplaces can also produce carbon monoxide. If there is not good airflow to the base of the fire, then the air in the fireplace will quickly lose its oxygen and incomplete combustion happens. But often with fireplaces, the airflow can be so bad that the carbon product equation occurs, where soot is produced. The amount of soot you see in your fireplace is a good indicator of how good or how poorly your airflow is. And if you see a lot of soot, both types of incomplete combustion are occurring, so you will have carbon monoxide production too. Now, most of it flows out of the house through the chimney, but if too much carbon monoxide is made and the chimney flue is not completely clear, there can be a buildup of this poisonous gas. Unfortunately, carbon monoxide has no color or odor, so it is not easy to identify. But as long as there is good ventilation in the chimney, you don't have to be too concerned about it coming into the house. This is one of the reasons why understanding chemistry is helpful to you, even if you do not become a scientist. Chemistry is involved in all aspects of our lives, and understanding the concerns of incomplete combustion is one important subject.